start sharing my screen. And let's see.
Professor,
Yeah.
when is the exam due by?
I just pulled the screen up because I saw that question in the chat. Exam
Thank you.
2 is on probability. It's going to be due by 11:59 on the 25th, which is Sunday.
Okay, thank you very much.
And it will be available after class today.
Okay.
Homeworks 12 and 13 are due by the end of the day today. In terms of my agenda for class today, I have 3 things that I want to do. 1, I want to make sure that nobody has any remaining questions on any of the homework. 2, I want to go over their practice test. And 3, if there's time, you guys ask me to show you what that next project is, and I'll upload that to Blackboard.
Handouts for today for that practice test?
Thank you.
We're going to go over the practice test today, Gina.
Is there something that we can print off?
Yeah, it's in Blackboard and handouts. I thought I had told you guys that last week.
You did probably. I forget. Sometimes my screen will like jump out from when I'm in different things. So I didn't print it out yet. So
Okay, all right.
Right.
I usually condense them, but because I'm giving them to you virtually, I'm giving you my spread out version that I usually went over on the document camera with. So, excuse me, first things first, how about homework questions? I know I got a few emails from both sections because I also teach a Monday, Wednesday, Friday section of this class about some of those expected value questions. Does anybody want to look at any of the expected value questions or any of the other homework questions, the assignment before that dealt with conditional probability?
I have some questions.
Sure.
It was on the hold on, the last homework we just did, not the one that's due today, but the one that was due on the 20th, I think. Sorry, I'm multitasking here. And there was 3 towards the end that I don't know if it was because I was doing them late at night or.
So like there were 27 questions. So do you want me to like randomly open 25 and see if that's one of the ones?
Yeah, exactly. Thank you. It was like
Okay.
20, 23. I think they were like different. I think this, I thought I was usually I get the spinner ones right, but I don't know. I don't think I did good in this one.
Okay, the one that I opened up 25 is an odds question. It says it's computed that when a basketball player shoots a free throw, the odds in favor of his making it are 21-7. Find the probability that when the basketball player shoots a free throw, he misses it. Out of every 100 free throw attempts, how many should he make? Is that one of them, hon?
Yeah, definitely. Because it involves sports and I just automatically shut down.
Okay, so because we know the odds in favor are, the odds for him making it are 21-7. The odds against him making it are 7-21.
Okay.
And now once we have the odds, if the odds is some ratio A to B, remember we said that the probability would be the first number over the sum of the two, A plus B. So the probability against him making the shot, which would be the probability of him missing the shot, would be the first number, 7, over the sum of the two, 7 plus 21, which gives me 7 over 28. And I think that might reduce to 1/4.
So much clearer when you do it.
Does that make sense, hon?
It
If
does
you-
make sense when you explain it like that.
When you have odds and you want to turn it to probability, it's the first number over the sum of the two. And so here we're saying that that probability is 1/4. Yes, we did it. Now, second part says, how many should he make? Well, that 1/4 is the probability that he misses.
Mm-hmm.
And so wouldn't the probability that he makes it be 1 minus that? If he misses 1/4, shouldn't he make 3/4?
Oh. Okay.
And somebody had sent me this question because they were using the 1/4 to find the number of shots. But this time we want him to make the shots. And so if he's going to make 3/4 of the shots and he takes 100, when I multiply, doesn't that tell me that he's supposed to make 75 shots out of the 100? Wow, I can't believe I got one with such nice round numbers. I think the ones that I was working on with other people during the course of the week had fractions that were not quite as nice as 1/4 and 3/4. And so those products turned out to be decimals and you had a round.
Okay. So you started to say when you have odds, the first, can you finish the rest of that sentence?
If you know the odds, if the odds is some ratio A to B,
Mm-hmm.
the probability is the first number, A, over the sum of the two, A plus B.
Sum of the two. Okay, so it's A over A plus B. Okay. Okay, and then I think there was one other. I think, you know what? It was the tables, and I usually do good with that, but I think when it's the millions, that throws off my numbers and my math, and I do those wrong.
You know what? If it's got the word millions at the end, you can disregard the millions and just use the number in the table.
Just using them. Okay, I thought that, but for some reason, you know, sometimes I use the how to help me solve this problem
Mhm.
to like walk me through it, so then I can write out, when I write out the steps, it's better for me, and then I do the math, and then I'm like, how did I just get that wrong? I just did it with the computer.
Yeah. Okay. All right. Just you can disregard. And again, if you're doing them at home and you have a problem and the help me solve it isn't enough, please send me an email. There's some folks in class that I've been emailing with on a regular basis, and I don't know. I hope it's helping them. But you know, if the help me solve it isn't working for you, don't be afraid to shoot an email. I'm looking for a table one towards the end of this assignment, and all I'm seeing are odds ones. So if we don't find it now, do you want to send me an email and
I will. If I get stuck, I'll email you so that you can help walk me through the steps if I'm not getting them. I appreciate it.
Okay.
I think
And
the
now-
students were like in the middle of the homework,
That assignment or a different one?
that assignment.
Okay, then I shouldn't have closed that one. And did you have who in? I apologize, I didn't see who was talking.
It's probably like 15 or 16.
Okay, Connor.
Only.
Table, okay. Table shows the educational attainment of the population of Mars, ages 25 over, expressed in millions. Find the probability that a randomly selected Martian, age 25 or over, has not completed 4 years or more of college. So when I see that word not, the probability that they did not complete, and I'm going to leave the rest of the words out. But when I see that word not, you have to remember that it's 1 minus the probability that they did complete. And so what's the probability that somebody did complete 4 years or more of college? See, 4 years or more of college is over here.
Mm-hmm.
And we're not worried about whether it's a male or a female. We're just worried about everybody.
So
that's
41
41 over 176.
Okay.
And then when I do that subtraction, I get 135 over 176.
Okay, so when you do that subtraction, you subtract the one. Are you subtracting the one from the whole fraction or just like the top denominator or the bottom denominator? Like, where'd you get the 135 from?
When I subtract fractions, I have to think of them having a common denominator. So in my mind, I'm seeing that as 176 over 176
Mhm.
plus 41 over 176. The denominator stays. And then when I take 176 minus 41, I get 135.
Oh, okay. So
And I'm going to tell you that I'm lazy. In my laziness, because I know that 1 is going to be 176 over 176, when I subtract a fraction from 1, I usually in my head subtract the numerator from the denominator and then put it over the denominator. But this is the why of it.
okay.
If you want to show how you're doing it, always think of your 1 as being a fraction with that common denominator.
Always think of the one with fraction and common denominator.
Connor, is that one better for you, sir?
I think Connor was helping me. I don't think he had any trouble.
Okay. And
Oh yeah, sorry, I was muted. Yeah, I'm good.
yeah,
Thank you so
Oh.
much.
Michael, sorry about the cat. And Debbie's asking, do you know how to do that subtraction with your calculator?
Oh, no, have you seen my 1975 calculator beast? No, it's,
Did
I
you get
have-
a new one yet?
no, I haven't. I started my internship / job, and so I'm just like,
I did see something in the manual as to how to change it into a fraction, but when I went back, my computer wouldn't let me open the manual again, so I'll try, again later for you.
I'm going out this afternoon, so I'm gonna, that's on my list to purchase as a new calculator.
When you
Great.
get the new calculator, it will help you a lot.
Yeah,
Like
I
the
just-
calculator, I love my calculator. Like I don't know what I would do with without it.
I use, not for nothing, but I go to websites, I go to math websites just to help me sometimes, but
You
That's
should
another
be able to download a TI 30 to your phone to use.
really?
Or do you-
I think there might be a TI 30 app. I'm not positive, but there's a good chance. After class, look for it, not during class time, no.
Okay, thank you.
Anybody else have a question on this homework?
I don't necessarily have a question on the homework. How did you, what Debbie said, how do you do the 1 minus the fraction thing on the calculator?
Okay, with your calculator, do you have it in front of you?
Yeah.
Okay, things I forget to do. 1, turn it on. 2, clear it. Then you're gonna go 1
Okay.
minus, and then to put the fraction, what was it, 135 over, no, let's do an easy one. Let's do 3/4. So we're
Yeah.
gonna go 1 minus, and then we're gonna type 3 divided by 4.
Okay.
And now before you do anything else, I want you to look at your display. Doesn't your display look like 1 minus 3/4?
Yeah.
Yeah. So now hit equals.
Okay.
And now, as you look at the face of your calculator, if you have the same calculator as I, in a different color written above the PRB button, do you see F arrow D?
Yeah.
What that does is that changes a fraction into a decimal or a decimal into a fraction. But because it's a different color, in order to get there, you have to press the pretty colored second button. So I'm going to press second FD.
Yeah.
And then when you hit enter, it gives you your answer as a fraction.
Oh, okay. Thank you.
Okay.
Yeah.
All right. Any other questions on any other homeworks before we look at that practice test? You guys, I'm not really a patient person, but I want to wait and make sure nobody has a question before we go on. Should we look at the practice test, or do we want to spend a little bit more time on the homework? I need an answer.
Practice test.
Practice test. That's what I was doing. I was going to get a little.
All right, so then I'm looking at, it's called exam 2 review spaced. And again, it's called spaced because usually I kind of don't leave spaces in between problems to show work when I do it as a handout in class in order, in a desperate attempt to save trees. But because we're doing it virtually, we don't have to worry about saving the trees. So question 1 says a car, it should be a car, not a cart, can be leased with a manual or an automatic transmission with 2 or 4 doors and in 1 of 5 colors. How many different cars can be leased? With this unit, with this test, I always look for keywords like this. Is everybody all right? How many tells me that my answer is going to be a whole number.
That's fair.
In order to find that whole number, I need to decide, is this a permutation or combination or just the counting principle? As I make that decision, does everybody see how many decisions do we have to make? How many things are we picking from? We're picking from the
4 different things.
transmission. What else are we picking?
The
Number of doors, and what else are we picking?
Colors.
Colors. Now, how many choices do we have for that transmission?
2.
2. How many choices do we have in terms of how many doors we have?
2.
2. And how many colors do we have to pick from?
5.
5. So is everybody all right? This is that counting principle, and I've got 20 choices. Next question again is a how many. I know it's a whole number. 4-letter radio station call letters can be formed. If the first letter must be a W or a K, and letters can repeat. If they can repeat, that means we're not using P's or C's. That means we've got to use our counting principle. So we've got to pick 4 things. The first letter must be a W or a K. So how many choices do I have for that first letter?
2.
How many, then, if the letters can repeat, how many choices do I have for the next letter?
Another 2.
Oh, only the first one's a W or a K. The other
Oh,
can
right.
be anything.
So 4?
How many letters are in the alphabet?
Oh, I thought they were saying 4 letters.
No. Radio stations, it's a
26?
rule, the name of a radio station, it's 4 letters, right?
Oh my God.
And has anybody ever noticed radio stations around here, they always start with a W? And on the West Coast, they always start with a K. I think on one side of the country, they start with W, and the other side, they start with K. At least that's been my life experience. So, and so that's where I made up that question from. And so multiplying that out, there can be 35,152 different call letters. Next one's not that different, except instead of letters, we're looking at numbers. We need 8. 1, 2, 3, 4, 5, 6, 7, 8. Now, when you look at your Banner Web number, 0 is okay, right? It could even start with a 0. So 0 through 9 tells me I have 10 choices for each. That would give me, if you're a glutton for punishment, you multiply that out. Otherwise, you might use an exponent, 10 to the 8th. And it gives me an awful lot of Banner Web numbers, 100 million.
How'd you get the 10?
When I'm looking at how many digits there are, because we work in a base 10 number system, there are 10 digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9 gives me 10 digits.
Okay.
Okay. Question 4 is a how many, but we're worried about orders. That word order tells me what am I probably going to use to figure this out. If it's
Permutation.
permutation, if order matters, it's a permutation.
Oh, yeah.
There are 5, and we want to use all of them. That's 5p5. And 5p5 equals 120. That one all right.
Yep.
Next one is also how many. And if the roles are different, that's telling me that the order matters. Does it make a difference to you whether you're the lead character or an extra? Yes, it's that because those positions are different, order matters. We have 10 people to pick from, and we get to pick 2. And 10p2, again, if you're somebody who doesn't have that permutation function on your calculator, the 2 tells me I have 2 slots. The 10 says tells me the first one is 10. The next one would then be 9. That gives me 90. I promise there's a question like this on the test where you're asked for the arrangements of the letters in a word where some letters repeat. Does everybody remember this letter has word, pardon me, has 1, 2, 3, 4, 5, 6, 7 letters. Since it has 7 letters, if they were all different, it would be 7 factorial. But they're not all different. What repeats?
A.
And how many A's are there?
There's 3.
So we have to divide by 3 factorial. Anything else repeat?
A repeat or N twice.
N's, and so we also have to, there's 2 N's, so we also have to divide by 2 factorial. If you're entering this in your calculator, remember, you've got to put a parentheses around that denominator in your calculator. With my calculator, I'm going to go, here, what's in there? 7 probability, arrow over to factorial, divide it by, open parentheses, 3 probability, arrow over to their factorial, 2 probability, arrow over to their factorial, close parentheses, and I get 420. That one all right. I promise there's one like that on the test. Only one, but it's there. Next question, how many? So I'm getting a counting number. I want a committee. Does everybody remember rule of thumb? Committees don't, order does not matter. Committees,
Combination.
combinations. First number has to be the larger of the 2. How many people do we have to pick from?
7. Oh, sorry.
8. And we want to choose 5. And so 8, probability, arrow over to combination 5, gives me 56. Is there anybody who needs to see how to do a combination by hand? Or are we all using calculators for this?
I like to do that by hand sometimes. It makes more sense to me.
Okay, if you're doing it by hand, combination 5, that goes in the denominator 5 factorial. 5, 4, 3, 2, 1. And now in the numerator, I'm going to start with 8 but I want to make sure I have the same number of factors in the numerator as in the denominator.
Same number, okay, same number of factors, same number.
So if I usually do the denominator first, and then I try to line up my factors to make sure they're the same number of them. This is different than how my labs would have you do it. My labs would have you do 8 factorial over 5 factorial, 3 factorial. But back in ancient times, when we used to always do it by hand, this was the easiest way.
So you multiply those, you cross out the numbers that match, right?
Right.
And then
mul-
you multiply 876.
Yep.
And then 321, and then divide?
Yes.
Okay.
Next question, should my answer be a whole number or a fraction?
A whole number?
Whole number. When I see that word and, it usually tells me I'm going to multiply. When I see that word committee, it tells me I'm going to have a combination. But does everybody see, because I'm making a committee of men and women, I need 2 combinations. I need 1 combination for the men and 1 combination for the women. I have 7 men to pick from, and I want 3 of them. I have 6 women to pick from, and I want 4 of them. So 7 combination 3 is 765 over 321 is 35. 6 combination 4 is, I think, 15. And so when I multiply, I get 525.
Yep, that's what I got on the calculator.
Next one, I think on the test, it's because they're my lab's questions and not handwritten questions, it might be split up over a couple of different questions. Multiple choice quiz has 10 questions, each with 3 choices. So everybody remember, if I've got 10 questions, each with 3 choices, that's saying I have 10 things. And each of them has 3 choices. And we're going to multiply those. So that gives me 3 to the 10th, which is, wow, 59,049 ways of answering this quiz. And that's going to be my final answer because it says how many. Next part asks for a probability. And when I see that word probability, I think now I've got to make a fraction. My probability fraction, the denominator is the total number of ways. And we just figured that out. 59,049. How many ways can you answer that quiz and get a perfect square? Isn't there a score, pardon me, isn't there only one?
Mhm.
So that probability would be 1 over 59,049.
If that type of question is on the quiz, that's gonna trip me up. I'm gonna think way too hard about that.
Just remember, if you're doing something like a quiz where you have to pick all sorts of different things, remember each question is a different choice. And you have to say, how many do I have to pick from for that?
Right.
Right, and remember when you see that word probability, your answer is a fraction. On the pencil and paper test, if people would get the denominator right, but maybe forget to put it in a fraction, usually they'd get half credit.
Okay.
What if it was
Somebody-
what if it wasn't like 100% though?
It would be beyond the scope of this course.
Oh,
Okay, in order to figure out all of the other different ways, it would pretty much be beyond the scope of this course.
Yeah, because I was sitting there like, what am I supposed to multiply to get the top number? Like, but the way you said it, you were like, well, how many ways can you get a 100 on a test? Well, one way you get a 100. Like, duh.
If you wanted a way of getting that one multiplying,
I
for
don't.
each of those 10 questions, there's only one right answer.
Right.
Well, you take 1/3 time to the power of 10 too, and then you're just multiplying the denominator, and then of course 1 to the power of 10 is 1. So it's the same as above there too.
I like that line of reasoning. The probability of getting any question right is 1/3. And so that would also you could also do that 1/3 to the 10. Very cool.
So that makes it more honed to your line, yeah, like multiplying.
Yeah.
Instead of doing like a little gimmick kind of to get the answer. In a way, you know what I mean?
I know what you're saying, Josh. Joshua.
If your mind is like more, because mine is very concise like that. I can't just,
Okay.
see, oh, now you just take the denominator and it answers a whole new question. It's like, wait, well, how did I get it though?
Yeah.
But yeah.
Usually if it's a two-part question like that, and the first part is a how many and the second part is the probability, the how many is supposed to help you figure out the entire sample space. That's why those questions put back to back. Next one, similar yet different. To win a lottery, one must correctly select 5 numbers from 48 numbers. The order in which the selection made does not matter. Everybody all right? Order does not matter. Shouts out to me. Combination. I'm going to pick 48. I'm going to pick from 48. I'm going to choose 5. Probability tells me this answer's got to be a fraction. And that's my entire sample space. There's only one winning combination, so that numerator will be 1. So that gives me 1 over. This one, Gina, I would not want to do by hand. This one I would want to do by calculator because the numbers become overwhelming. So
That's fair.
48 combination 5 gives me 1,712,304 different ways that I can choose my 5 numbers. And again, only one is the winner. Again, because some of these questions have parts A and B, these 10 questions are probably about a dozen or so questions on the test split up.
wait, how did you get that one? Because it said one must.
There's only one winning combination of numbers,
Okay, all right.
okay? And I promise, I think the one on the test initially looks like that white ball, gold ball one, but we're only looking for one winner on the test. Six-sided die is rolled. Find the probability of rolling the number 5. Help. What's the probability of getting a 5 on a die?
1 out of 6.
1 out of 6. Beautiful. How about a number bigger than 4?
1/2.
Bigger than 4. Let's see.
Bigger for 2 6.
2 6. And now 2 6, I would give you full credit for. My labs won't, which is why you gotta submit pencil and paper work so I can give you partial credit. My labs would look for the reduced form of that 1/3. Number less than 8.
6, 1.
6, 6, which is 1. And remember, if something must occur, its probability is 1. Number bigger than 6. How many of them? 0 out of 6, which is 0. If something's impossible, its probability is 0. What's the probability of not getting a 3?
5, 6.
We could look at it, look at our sample space and realize that 5 out of 6 are not 3, which is perfectly fine. Otherwise, when I see that word not, I always think 1 minus the probability that it does occur. And that would also take me to that 5, 6. Let me double check. I do believe that in my labs, when there's a card question, they give you a picture of a deck of cards. If they don't, before, and on the off chance that they don't, before, and you're not comfortable with cards, before you open the test, please go to, in Blackboard, please, in content, in handouts, please open the picture of a deck of cards. Open it, save that document somewhere so that when you are taking the test in my labs, you can, oh. It's taking its time. I must be having too many things open. Anyways, it'll give you that picture of a deck of cards, all right? So if you're not comfortable with cards, if you don't remember what's in a deck of cards, print that out or pull that up and save it somewhere before you start taking the test. It asks about a face card. The faces are on the Jack, Queen, King. And so when I count up, there are 12 of them. And so the probability of getting a face card would be 12 out of 52. Again, if you give me that, I will accept that. However, my labs won't. They want you to reduce it to 4/13. The probability of getting a club, looking at that picture, I would count 13 of the 52 club cards are clubs. Or looking at that picture, I could see that a quarter of the cards.
Wouldn't the reduce be 3/13?
Yes,
instead
it
of-
would. Thank you for catching me. It's a lame excuse, but I think I need another cup of coffee this morning.
That is a completely valid reason.
Okay, so now the next one is a tricky one. It says, what's the probability of getting a face card or a club? Face card is that, I apologize, I want to go to the unreduced form, 12 out of 52. Club is that 13 out of 52. The word or tells me to add. But if I go back to my picture, if I look at the clubs, oh, this isn't going to let me circle them. If I look at the clubs and look at the face cards, does everybody remember there are 3 cards that are being counted twice? And I can't do that. And so I have to go back and subtract those cards that are being counted twice. And so that would give me 22 out of 52, which would reduce to 11 over 26. When I see that word not, I italicized it on the pencil and paper test. Words like that are not italicized in my lab, but those are keywords to look for. Probability of something not happening is 1 minus the probability that it does happen. 4 of the 52 cards are queens. Subtracting that'll give me 48 of the 52 are not queens. And that would reduce to 12 13ths.
Wait, can you say that again?
The probability of something not occurring
Mm-hmm.
is always 1 minus the probability that it does occur.
Mhm.
The probability of a queen is 4 out of 52. When I take
Mhm.
1 minus 4 out of 52, that gives me 48 out of 52, which reduces to 12 13ths. I'm guessing if you're doing this subtraction on your calculator and use the fraction to decimal button, you won't get that middle number. It'll take you right to the reduced end, which is fine. Next thing you have to be careful of, when you're asked for odds, you have to find the probability that it happens, and you have to find the probability that it does not happen. So the probability of an ace is 4 out of 52, or 1 13th. The probability of no ace, again, when I want the probability of something not occurring, I'll subtract from 1, and that gives me 12 13ths. So I want to make sure my fractions have the same denominator. If it does, my odds are the ratio of the numerators. When I look for the odds against, I just reverse that. It's the probability of no to the probability of yes.
And so for E, it's 1 because you're only drawing one card, right? Like 112. It's 1 because you're only drawing one card.
It's 1, not because I'm only drawing one card, but because the probability of an ace is 1 out of 13.
Oh, okay.
I have to find the probability of an ace. 4 out of 52 gives me 1 out of 13. And then for the second half, for the not probability, I always just subtract that from 1, which gives me 12 out of 13.
Okay.
And I take the ratio of the numerators. So over here, if I want the probability of a red card, well, the diamonds and hearts are red. If you count on the picture, 26 out of 52 cards are red. Or half the deck is red. So if I want the probability that it's not red, that would be 1 minus a half, which is also a half. And so for the odds, I'm taking the ratio of those numerators, which actually just gives me 1 to 1. Next question, we're asking for a number. So I know my answer is a whole number. It's cards. And we said that with cards, order usually does not matter. So it's a combination. 5 card hands possible. There's 52 cards and I want 5 of them. And I have to apologize. Usually by this point in the semester, I've got that number memorized. but today it's not a happening thing. So 52 combination 5 is 2598960. So there's a lot of different hands. How many ways can I get 5 cards that are just hearts? Cards are combinations. I'm choosing 5. But if I want it to be a heart, is everybody all right? There are only 13 hearts in my deck. If you're not sure of that, you can look at that picture of cards and count the hearts. So that'll give me 13 combination 5, which is 1, 2, 8, 7. Third part asks for a probability. Probability is a fraction. The top of the fraction is what I want. So what I want is 5 hearts. The denominator are all the possible hands, the whole sample space. And this is one where you don't want to reinvent the wheel. We found the number of ways I can get 5 hearts. 1, 2, 8, 7. And we found the number of total hands possible. 2, 5, 9, 8, 9, 6, 0. If you put this in MyLabs the way it's written, they're going to yell at you and tell you that you have to reduce it. But I know that calculators don't reduce fractions that large easily, and I don't want you to get hung up reducing the fraction. So if you have that non-reduced, even though MyLabs won't give you credit, I will give you full credit myself. Don't get hung up on doing things like reducing big fractions like that. We're studying probability, not fractions. All right? And again, that is why I must have you submit your work. Have I said that often enough? I think you've seen this question a couple of times in class and a couple of times in the homework. There is one of these. What's the probability of flooding in 1 year is 1/5. What's the probability of flooding 2 years? Remember, we said weather is independent. So we're going to just multiply that probability once for each year. Flooding in 4 years, we'll do that 4 times. Which gives me 1/625. The probability of no flood in 1 year. When I see that word no, I need to subtract it from 1. So no flood for 3 years would be that number times itself 3 times. Or some of you might prefer to do the 4/5 to the 3rd. Either way will give me 64 over 125.
You're going through this like so smoothly and so great, and it's awesome. And that's like, oh, that makes total sense. Like, yeah, that makes sense. And I know that when I'm doing the test, I'm gonna sit there and stare at this, and like smoke is gonna come out of my ears for like 5 seconds, 5 minutes
Right.
before I
I feel the same way. The
Can I
same
make a
you
suggestion?
know. I get it, but I know that like I'm just gonna be like, wait, which way am I supposed to do this one again?
You have until Sunday to finish this test.
So we can start it and stop it?
No. You
No?
have to do it all in one sitting, because if people start and stop, what happens is that gives people the time to look things up in between, and I don't want that
Right.
to happen in a test.
That's
But
fair.
what I would suggest is print this thing out. Do it
and
twice.
yeah.
Watch
might do
this
that.
class twice. Get yourself
makes sense.
comfortable with these before you try it.
Okay.
Go over your homework, because these are questions that I wrote by hand. The test, because of the being virtual, is going to be MyLab's questions. So look over your homework. The MyLab's questions are most likely questions that were on your homework already.
Oh, okay.
Okay?
Okay.
If you go in and take the test cold, yes, it's nerve-wracking and you feel underprepared. But practice, 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 practice. Okay?
Is the test in the same order as this?
Close, but not necessarily. But what I did was I left the questions in the order in which they came in MyLabs. So the beginning questions are from the first section and the ending questions are from the last section. So they're presented in the order in which we learn the content. I didn't jumble the order up. I started with section 11.1 and pulled out a handful of questions, then 11.2, 11.3. So they're in that order.
Okay.
Uh-oh. Magic words, expected value. Does everybody, when you see those magic words, immediately think table?
Yes.
In the table, we want to know what can happen, what's the value of that happening, what's the probability of that happening, and then I'm going to multiply the value by the probability to get a product.
I'm sorry to interrupt you.
Yeah.
Have we finished letter E from the last problem?
Oh, no, we didn't.
Oh, I just wanted to, I think I know how to do it. I just want to double check and go over.
Want to tell us how to do
Yeah, sure. So I think that as a rule, to find the probability that it'll happen at least once, you take 1 and you subtract the probability that it will not happen at all. Is that right?
Uh-huh.
Okay, so I got 61 over 125.
Because we already figured out the probability that it will not happen at all. Beautiful.
All right, cool. Thank you.
I got distracted and didn't finish it. I'm so sorry.
No problem.
Oh, where's that coffee pot? Debbie, did you get me a coffee?
Yeah, right here. Here
Okay.
you go.
All right, pour it on the computer and I'll absorb it. No, they will ruin your computer. Okay, we are buying a raffle ticket. We can win the grand prize. We can win an additional prize. Or we cannot win. If the grand prize is $1,000, but I've paid $5 for the ticket, the value would be $995. If the additional prize is $250, I'd end up with $245. And if I don't win, I'm out by $5. I think everybody's comfortable with those two columns. Yes? Now for the probabilities, there are 1,000 tickets. Oh. How many of them, how many grand prizes are there?
Just one.
One. For the additional prize, there's still 1,000 tickets. How many additional prizes are there?
2.
2. There's 1,000 tickets. How many of those 1,000 tickets don't win anything?
997.
Beautiful. If there are 3 winners, sadly, that means there's 997 losers.
That's how life works.
Yeah. So multiplying across, the first product is a decimal is 0.995. Here, because it's money, I would multiply them to decimals. second product multiplying across is 490. Third product multiplying across, and remember it's going to be negative because I've got that negative sign. And so when I take 5 times 997 and divide it by 1,000, I get 4.985. And so when I add those, I get negative 3.5. And so I expect to lose $3.50.
I'm just wondering how you got the 997.
Okay. Are you all right? There's 3 winners.
Yeah.
And so if there's 1,000 tickets and 3 win, then the other 997 don't?
I was subtracting 5 from 1,000.
Okay.
Yep.
No, this is the 1,000 tickets, not the $1,000. The other way you can get that is you have to remember that this column always adds up to the number 1. And so I could add those 2 fractions and subtract from 1 to get that third entry.
Okay, now I get it.
But I have to erase my 1 because I put it in the middle of the next question. And I have to apologize. This 1, 2, 3, 4, 5, 6 on the test, the way it stands, because it's my labs, each one is a different question. It's not a question with 5 parts. And because each one is a different question, I have to apologize. Each one is going to be from a slightly different table. But this is like the Martian question that we looked at. So we've got to divide it by men and women. We've got to divide it by age. If I want to find the probability, so it's a fraction, that I have a man, the word given is not there. So my sample space is all of the people. And how many of those are men? 26098. And here, even with a pencil and paper test, if you didn't change it into a decimal, I would not give you full credit. So let's go through and let's divide that out. And round carefully. That gives me 0.863. If you don't round carefully, if you just take those first digits, this last digit would be off. My labs would not give you any credit. However, if I looked at your work and saw that you started with the right fraction, I would give you credit. I'd just take, like each question's worth 1 point, you would get 0.9 instead of a whole. Next, find probability. It's a fraction. The word given is not there, so we're using the whole sample space. I want somebody between 15 and 24. Here, you have to be careful because 15 and 24 covers 2 groups. So does it make sense? We need to add those 2 numbers. If you're typing this directly into your calculator, remember that whenever there's computation in either the numerator or the denominator, I need parentheses. And so is anybody else getting 0.224?
Yep.
I have to apologize. On my handwritten test, words like given, words like not, words like order, I tried to boldface to give people a clue. Blitzer in my labs doesn't. But in your mind, look for that word given. That word given says I'm not using the whole sample space. Given it was a male means that my sample space is just men. So my denominator is 26098. Of those men, how many were between 15 and 29? 2209. And I get 0.85. I'm sorry, 0.085. I misspoke. And again, on my test, these were back-to-back questions. I am unable to do that in my labs. But when we first read this next one, it looks real similar, except the order of the words is reversed. And that's a big difference. This time we're given it was a person in the 15 to 25 age range. And so that means I'm only looking at people in the 15 to 25, I'm sorry, 15 to 19. Where did the 25 come from? I apologize. 15 to 19 age range. And so here my sample space is 2474. How many of them are men? The same, 2209. And so this gives me 0.893. Is everybody all right with the difference between C and D?
When I was trying the practice, I did C for D and D for C. I would probably get it.
It's okay. When I see given it was a male, I actually personally go through and circle all the men.
Mhm.
And when I see given it was in that age range, I circle that age range. So that it helps me focus on just that part.
Okay.
Okay. Over 5, there's 2 ways of doing it. One way is we could add up all the people over 5, or we can say that it's not under 5. And so that would be 1 minus the probability that I have somebody under 5. There's no given. So here we're again using the whole sample space. And so when I take 1 minus that 71 over 30242, I get 0.998. And then lastly, this last part F, when I used to give this as a pencil and paper test in class, F, people would mess up because they try to restrict their sample space. But as I read, go ahead.
Wait, so why didn't you say the 5 to 12 and like divide it over the tree, the total?
Because over 5 isn't just 5 to 12, it's also 15 to 19, 20 to 24, it's everybody,
Oh,
right? There, if I, oh God, I don't want to tell you my age, but my age is kind of towards the right of the table. I'm still over 5 years old. Do you know what I'm saying?
yeah.
Okay. This one, where people mess up is they don't use the entire sample space. As I look at it, does anybody see the word given at all? If the word given isn't there, my sample space is everybody. But in my numerator, I just want men under 20. Men under 20 would be under 5, between 5 and 12. And I guess that 15 to 19 should actually be 12 to 19, and I mistyped. And so when we add all of those, we'll put it over that denominator. "17, don't worry about, there's only one expected value on your test. There is something like 18 on your test. I know we only have 2 minutes left. So is everybody right if I kind of go through 18?
Yeah, go ahead.
Probability means it's a fraction. Cards tells me it's a combination. Whole sample set, there's 52 cards and I'm picking 5. Numerator is what I want. I want 4 kings. If the denominator is a combination, the numerator will consist of combination. There are 4 kings and I want all of them. And tells me to multiply. I want 1 jack. There's 4 jacks and I want 1 of them. So denominator, we already figured out. What was that? 2598960. Numerator, 4 combination, 4 is 1. 4 combination, 1 is 4. So the answer is 4 over 2598960. Is anybody in the class a golfer?
Used to be a long time ago.
The
Why?
last one I consider a gimme. An easy chip shot. Like, what's the probability of getting 5 aces? How many aces are in a deck?
4.
4. And you
So
get 5
0.
aces. So that probability is 0. And there we go.
Yay.
17's not on the test.
Pardon me?
You said 17's not on the test.
There's only one expected value on the test. And the
Okay.
expected value on the test, I believe, is like one of the ones that was on the homework. I think it was the expected value of some sort of game of chance.
Okay.
Okay?
Sounds good.
Can we go over the project?
Sure. For the project, the directions are somewhat involved. What you're going to do is you're going to find the expected value of a lottery scratch-off game. First thing you're going to do is you're going to go to the lottery website. Is this gonna let me go to the lottery website by just clicking?
I'm sorry, Professor. I have to go.
That's fine. This is just if people want to go over the project, and this will be recorded with class. All right?
Okay. Thank you. Have a good day.
You
Bye.
too. So I'm gonna go to the lottery website, and honestly, I'm gonna cheat a little bit here, guys. I think the easiest way to get there is to just Google up NYS Lotto. And it'll take you to the state lottery website. On the state lottery website, you are going to go to, oh, this looks different. Okay, you're going to go to games. This looks like what I wanted. You're going to go to games. You're going to go to scratch off games. And then you're going to pick $1. I only want you to use $1 game. And when I pick those dollar games, there are 12 of them. I don't care which one you use. Pick one of the games. High priority. When you do this, make sure you write down the name of your game. Because there are 12 games to pick from, I made answer sheets for all 12 games. But if I don't see the name of your game, I am not going to troll through and try to find the one that you did. You have to tell me which game you used, all right?
All right.
When you pick your game, you're going to go and you're going to scroll down, and there's a place, odds, prizes, and payouts. What you need from here is you need to write down the overall odds of winning. We need the prize amount and the odds of winning that prize. So we're focusing on these two columns.
And is that only for first place or the total, like everybody?
I don't understand what you're asking. Could you ask again, please?
Should we only write like the first prize?
No, for all of the prizes,
Oh, okay.
all of the prizes. Can I give you a hint? If you don't want to do too much work, don't pick a game with 13 prizes. I think there's one game that only has maybe 5 prizes. If I were doing this project as a student, I would look for the game with the smallest number of prizes. Okay? Then you're going to make note of the overall odds of winning. That's the odds against losing. Reverse it to get the odds of losing, and then change the odds to a probability. In the same way, you need to change the odds of each prize into a probability. The prize is the outcome. The value is going to be $1 less because you had to pay $1 for the game. What the table does not give you is the outcome of losing. You have to add that. And then you're going to find the expected value of your game. Write a brief report explaining what you did and what the expected value means, and submit it all. When I did this, when I go through and make my answer keys, I use a spreadsheet because I think it's easier. You don't have to, but you can. And so over here, I tried to, I actually tried to print out one of the pages from the current website, and it wouldn't let me. So this is something, the way it looked on the website last year, but it's focusing on the overall odds of winning the prize and the odds of winning that prize. And so I did an example for you. I included one of my spreadsheets. So what they don't have in there is losing. And so losing the prize is 0. The odds, well, the odds of winning was 1 to 4.23. So the odds of losing is 4.23 to 1. The value is -1. Remember, the probability is the first number over the sum of the two. So this came from 4.23 over, if I add 1 to that, 5.23. Next one, the prize is $500. So the value is $4.99. If the odds is this number, the colon's supposed to be in between them. The probability is 1 over, the total of those would be 1, 2, 3, 6, 0, 1. And that's where this crazy decimal comes from. My software put it into scientific notation. Scientific notation that would without would be 0.0000008. And then when I took the $4.99 and multiplied it by that, I got something like this. Carry more decimal places than you think you need. And can I tell you, when I fill in this table, if I were doing it without a spreadsheet, I would not do this column, and this column, but rather I would work sideways, because you'll have this number in your calculator. While it's in your calculator, it's easiest to just multiply it by this to get that number.
So
And so go ahead.
did you multiply 500 times 4.23? Or I'm just trying to figure out how you got the 1, 2, 3, 600 value.
Yeah. That number, oh, I'm sorry, my finger wasn't supposed to do that. That number came from the website. And again, this game is a different game than what you're going to see on the website, but that number would be from your, over here, the odds in your table.
Is that chart that you were looking at, is it on the thing with the quiz?
Yes, all of that, the example is in with the project.
Okay, all right.
Yeah, I'm not making you, yeah, don't worry, this example is in with the project. And so who was asking where that second number came from? Here, if the prize is $3,000, the odds are 1 to 519 120. So the value is $2,999. And here the probability would be 1 over 519121, because it's always the first number over the sum of the two. And so that number came from, and I have to apologize, when I copied the old website into the document, it lost clarity, but that number came from the odds on the website. Where'd it go? It just disappeared. How did that get over there crooked? Oh, Lord. So it came right from there. And so you're going to do that for all of those possible entries. And then after you do that, you're going to total it up. And the expected value over here is negative 0.42273. And so because this is money, I'd say that the expected value is negative 42 cents. You expect to lose money. heads up. All of the answers are relatively close. So you should expect to be losing something pretty close to 40 cents. So on the dollar, when you pay $1 for the scratch off game, you're actually just donating most of the money to the state, a good portion of the money to the state. So, but it's an expected value with a real life application. We can go over this again on Tuesday. It won't be due until a week from Tuesday. But I know some people asked to look at it this weekend.
Okay.
Okay?
Yep.
Those of you who want to try it over the weekend, hopefully that was enough. If it wasn't, shoot me an email if you have questions. The test you only get one shot at. It's due by midnight on Sunday. And you must submit your work in Blackboard. I just found out, I think there were a couple of times where I told people I couldn't access your work from Blackboard. I found out from somebody that if I can't access your work from Blackboard, it's because you didn't finish submitting it. So you have to kind of hit whatever the last button it is to say that you've submitted it in order for me to be able to access it. If there's any problems with that, please don't throw away your work. If I can't access it in Blackboard, I'll send you an email and ask you to send it to me via email. So any questions?